Okay, everybody, this is a video for today's Wednesday. We're going to get in more real-world situations with geometric sequences and series. Okay, so here's like a pendulum on a clock. Here's my little clock. Here's a little pendulum. And I talked about it in one of my periods today I got ahead. Anyway, my initial arc length of one swing is 18 inches. So from here to here is 18 inches, okay? On each successive swing, the arc length is 0.98 of the previous swing. So it's basically 0.02 or 2% decrease. So it's a 2% decrease because that's 0.02 less than 1. But anyway, that's my little, it's going to be our common ratio. It's 0.98. Notice the first swing is 18 inches. The second swing has an arc of 18 inches times 0.98. The third will be 18 inches times 0.98 times 0.98. The fourth will have 18 inches times 0.98, 0.98, 0.98. You get the picture, right? We apply the common ratio 3 times to the third power for the fourth term, n minus 1. 4 minus 1 is 3. Okay? So here's our questions. Let's write a formula for the nth term and find the arc length of the 10th swing. Okay, so a sub n, the nth term equals my first term times the ratio to n minus 1. Well, my first term is 18 inches from right here, okay, times 0.98. That's our common ratio. Everything's times 0.98 to n minus 1. All right, so for the 10th swing, that's 18 times 0.98 to the 10 minus 1. I plug in 10. This is dummy proof. Okay, so it'll be 0.98 to the 9th power times 18, and it gives me 15.007 inches. Okay, look at B. On which swing is the arc first, this is written kind of poorly, but on which swing is the arc going to be less than 12 inches? So it could be less on a lot of different swings, but when is it first going to be less than 12 inches? Okay, so on which swing is the arc going to be first less than 12 inches? Okay, so we take what? A sub 1 times r to n minus 1, okay, the nth term. And we set it equal to 12, okay? We're setting it equal to 12 inches. So 18 times 0.98 to the n minus 1 equals 12, okay? And notice what I did. I want to get this term. We're going to have to solve for an exponent, okay? Our variable is in the exponent, so we need to get that down. So we need to get this whole term by itself, okay? So we're going to eventually take the log. Natural log or common log. It's not going to matter. So anyway, we're going to get 0.98 to the n minus 1 by itself. So we'll divide by 18 for both sides, and that cancels out, and I'm left with 0.98 to this n minus 1, and it equals 2/3, which is 12 over 18 is 2/3. All right, when you want to solve for an exponent, if you take the log, this comes down. This right here and this right here are the same thing. Okay, I'll show you why tomorrow if you have a question why this rule works. But if you take a log of something, the exponent is allowed to come down and be a coefficient. Okay, it has to do with addition properties of logarithms. Okay, and multiplication problems. All right, I can show you tomorrow. All right, so now I've got this since I took the natural log, and you could do log log too. But notice I did it to both sides. Right, log of the natural log of this, natural log of this. Now I brought this n minus 1 down in front, okay, and now I just have to get this by itself, the n minus 1, right? So I divide both sides by what? This log, this whole thing, the natural log of 0.98 divided by the natural log of 0.98, okay, that cancels out, and I get n minus 1 equals the natural log of 2/3 divided by the natural log of 0.98, okay? You have to have a log here and a log here, okay? You just can't do a log. Okay, this is natural log. You need 2 logs, okay? All right, so I'll get an answer here. N minus 1 equals 20.069. So guess what? I add 1 to both sides, and n equals this. So actually, it takes 21.069 swings to get to equal 12, okay? We want to be less than 12, so I got to go up to the next, so my final answer is a 22nd swing, okay? I can't do this. I need to be 1, so the first swing that gets me less then 12 inches is a 20-second swing. All right, so here's another question. So after 15 swings, what will be the total distance that the pendulum will have swung? Okay, so if we're going to do after 15 swings, what's add up all those arc lengths, okay? All right, so I'll show you both ways, and you get the exact same answer. So here's my finite sum equation, a sub 1 times 1 minus r to the n over 1 minus r. So 18, my first term, times parentheses 1 minus 0.98 to the 15th over 1 minus 0.98 equals this. The other way was, notice I put in the formula for the nth term, 18 times 0.98 to the n minus 1, and I use sigma notation, which just means we're going to sum up every term that this produces. Plug in 1, 2, 3, all the way up to what? So n equals 1, all the way up to 15. The computer will what? Plug in a 1, a 2, a 3, a 4, a 5, and spit out 15 terms and add them, but you put in this format, okay? N equals 1 to the 15th power, and you plug in your nth term formula, 18 times 0.98 to n minus 1. And both ones get the exact same answer. Okay? When it stops, finally, after all this, what will be the total distance traveled, total arc length? Okay? This is kind of an infinity question. I mean, this thing's going to swing back and forth for a long time, so let's just find the infinity function, okay? First, can we use this function? Yes. My common ratio is less than 1. The absolute value of 0.98 is 0.98, and that is less than 1. So we can find an infinite value of infinite swings. 18 over 1 minus 0.98 is 18 over 0.02, ends up being 900. And that'll be in inches, okay? So we should work some problems like that tomorrow, some more real world. And we'll use, don't forget, we can use sigma notation if you want in the calculator. So that's all I have, okay? We'll see you tomorrow. Hope everyone did well in the test. Thanks.